Have you ever wondered how doctors can look inside your body without even making a single cut? That's the magic of MRI. But actually, it's not magic at all. It's just physics. What is an MRI? MRI stands for magnetic resonance imaging. It's a medical scanning technique that creates detailed images of the inside of your body, especially your soft tissues like your brain, muscles, and organs. No x-ray, no surgery, no pain. But how does it work? To answer that, we'll need to zoom in way into the tiniest building blocks of your body. Most of your body is made of water, and this water is made of hydrogen and oxygen. Hydrogen atoms have one single proton in their nucleus, and this proton acts like a tiny magnet. We can call this magnetic property a spin. When your body is placed inside an MRI machine, which has a very strong magnetic field, those tiny spinning protons start to line up with the magnetic field, kind of like how a compass lines up with Earth's magnetic field. This alignment creates something called a net magnetization. Now, here's where things get exciting. Literally, the MRI machine sends a pulse of energy using radio waves called the RF, radio frequency pulse. This pulse is turned into something called the Lamarck frequency, which is a natural spinning speed of the hydrogen protons in its magnetic field. When the RF pulse hits, it gives the proton a little kick and tips them out of alignment with the magnetic field. It also makes them spin in sync in a state called the phase coherence. As soon as the RF pulse stops, the protons begin to relax. While doing so, they release energy, and this energy is picked up by a special coil, kind of like an antenna, and this signal we use to build the image. But the story doesn't stop here. The protons don't all relax the same way. In fact, they do two things at once. First, they start to fall out of sync with each other. This loss of spin coordination is called a T2 relaxation. Second, they gradually realign with the magnetic field. This is called the T1 relaxation. Different tissues in the body have different T1 and T2 times. Fat relaxes quickly, water relaxes more slowly. That difference is what gives us contrast in the MRI images, so we can tell one tissue from another. Now we've got signals coming from different parts of the body. But how do we turn that into an image? MRI machines use something called gradient magnetic fields. These are small, adjustable magnetic fields that vary across the body. They make the Lamarck frequency slightly different in different locations, allowing us to know exactly where each signal is coming from. By collecting all these signals and running them through something called a Fourier transform math tool, we can turn that data into a detailed 2D or 3D image. MRI machines can do even more with preparation sequences. For example, inversion recovery flips the direction of protons spinning before measuring them. Why? Because this can help highlight certain tissues, like white matter in the brain, or suppress others, like fat. Another key factor is the signal-to-noise ratio, or SNR. A stronger magnetic field means more protons align, giving us a stronger signal and a clearer image. MRI is extremely safe. Unlike X-rays or CT scans, it doesn't use ionizing radiation. It's especially good for imaging soft tissues, brains, spinal cords, and joints, and even tumors. That's why it's such an important tool in medicine. MRI has revolutionized modern medicine. It lets doctors detect problems deep inside the body without surgery and without radiation. From diagnosing strokes to tracking cancer to mapping brain functions, MRI is one of the most powerful tools we have. And it all works because of physics, magnetic fields, radio waves, spinning protons, and a bit of clever engineering. So next time you see an MRI image of a brain or a knee or a spine, remember, behind every image is a world of physics, quietly spinning away inside your body. Thank you for watching my video. I hope this was useful and you learned the relationship physics has with MRI machines and how MRI machines are so helpful to us in our everyday life.